Hi everyone, welcome back. This is Samuel. I'm an AWS and DevOps architect with over 20 years of experience in IT. And today I'm going to talk to you about a real world AWS success story that proves what's possible with the cloud. Imagine that you're expanding to multiple global regions in just 3 weeks. Sounds intense, right? Well, UNiDAYS did exactly that using a serverless architecture. Serverless, containers, and having a global database, and even more. So let's break down that architecture, do a tech teach, and know how you can apply the same strategy. All right. So what's UNiDAYS? UNiDAYS is an student discount program platform which supports customers or users in 113 different countries. So the business challenge they had was they had global users and had AWS IT infrastructure in one place, and that was creating a high latency for remote users. The local users were all fine, but the remote users were having problem. And they wanted to do an regional expansion, not just add more to the existing region, but they wanted to have or expand to another region so we can locally serve the customers from that region. And they wanted to deploy. So the goal was to deploy to new AWS region in less than 3 weeks. So let's understand how they did it. So by the end of this video, you'll understand how to architect a globally scalable system on AWS. That's what we're going to learn. And then how to use services like ECS, how to use services like DynamoDB, and especially global tables and get benefited by that replication, and how to use EventBridge, and how to use CloudFormation. UNiDAYS used all of that, and that's how they were able to achieve this regional expansion. And you're also going to learn how UNiDAYS achieved 75% latency deduction, and also how they achieved 100% uptime using cloud. Ready? Let's dive in. So, like we discussed, they had the challenge was they had high latency for global audiences, and they wanted lower latency for those global audiences, and they wanted higher availability across the continents, and they wanted a fast deployment in a new region in less than 3 weeks. So they didn't just move fast, they actually built it fast. This wasn't migration, this was building, right? So they built it really fast in less than 3 weeks. That's what happened. So before we go further, let's understand the AWS architecture, the final one, or the finally built one they have right now. So it all starts with Amazon Route 53, this little guy sitting here. That's the AWS DNS service. It actually routes users' traffic to the nearest AWS region using latency based routing. That's a configuration in Amazon Route 53. Now that means that users in Europe hit the EU backend, and the users in US go to the US service automatically. Look at what this Route 53 is serving. Route 53 is serving region in US East 1, in other words, a region in the US, or an IT infrastructure set up in the US region, and it's also serving an IT infrastructure set up in European Union. So now it's doing something called as global routing, right? So it's routing traffic. First, it identifies where the user is coming from based on their IP, and then it identifies the country. It identifies the latency between the IT infrastructure and that country. It kind of compares both, and then it routes the traffic to the nearest cloud IT infra or IT region, let's put it that way, and routes that traffic to that particular region. So it's like this. It's like Google Map. Take that for example. It's like Google Map for the cloud, always choosing the fastest route, and that's what Route 53 does. All right. And then there is CloudFront. All right. So CloudFront, this person right here. So CloudFront is an content delivery network. It actually caches the static files near its users, and this improves load times dramatically for the users. right? So anytime a request comes in, not all the files and all the details needs to be streamed from here to the user. There are some static files that we can categorize and store them here and load them directly to the user from here. The logos, the JS file, the CSS files, they all can be stored or can be served to the user through CloudFront, and they all get loaded in milliseconds. So like half of, depending on how your application is, like half of your page gets loaded in milliseconds, and only the remaining gets pulled from its actual source, in this case ECS service. All right, and then so the user hits, goes to Route 53, some of the content gets served from CloudFront, and then the remaining content needs to get served from the actual ECS service running behind the scenes. All right, so let's talk about the second half of the content that needs to be loaded. All right, so the request then gets sent to Amazon load balancer. It's a regional level load balancer, which then balances the traffic across containers running on Amazon ECS. All right, so we could use ECS Fargate type or non-Fargate type. That's absolutely up to us, but there are some good reasons why we need to use Fargate. That's because they could spin up microservices much faster. They could spin up microservices on demand, and more importantly, Fargate is zero server maintenance. We really don't have to worry about maintaining that piece of infrastructure for that matter, right? So once you turn it on, it's on its own, right? It'll spin up faster, number one, and it can be on demand. If anything goes down, it'll automatically spin up by itself. Even if the infrastructure, for example, the underlying infrastructure host or something of that sort goes down, right? It's all automatic. Amazon takes care of it. Right? So that's why it's suggested that we pick ECS Fargate for ECS services. All right. Now let's talk about DynamoDB tables, especially global tables. So here's the magic. Amazon DynamoDB, right? It offers something called as global tables. The user data in these tables, right? Whichever user, assuming all of the whole infrastructure is serving the same set of users, the same set of content is being shown to them, and some data gets stored here, they automatically get replicated with the other DynamoDB table that's present in this other region, and it has its own benefit. We'll talk about that. So the user data is replicated automatically across all regions. This means no matter where the user is, the user could be in US, or the user could be in the European Union. No matter where the user is from, they're always working with the real-time and consistent data, right? Irrespective of whether the user got connected here to this region, to this ECS, or to the US region, to that ECS, they're working with real-time and consistent data, right? Another component that kind of stitches all of these together is Amazon Event Bridge. So Event Bridge is a service used to handle event-driven communication between services. We'll talk about event-driven communication or Event Bridge later in another video. All right. So for now, just understand that Event Bridge is a service that kind of handles event-driven communication between the services, and having that event-driven communication between the services kind of decouples the architecture. So the service does not have to talk to the other service directly. They talk to other service through events, right? So this kind of decouples the architecture and allow the service to evolve independently across the regions, right? So none of these here are tightly coupled. It's all event driven, right? Another best part is UNiDAYS used infrastructure automation tool called as CloudFormation, AWS CloudFormation, to spin up this infrastructure, which means one template could spin up the entire infrastructure in any region in just minutes. You might be familiar with console, clicking through multiple buttons and then entering values in those questions and prompts that are asked, and picking one from the list of options available, things like that, right? But if you already knew what you want, if you're clear about the size of the resource, what's allowed, what's not allowed, the version of the application, things like that, you can hard code them into a template and use that template to provision the infrastructure. All right. So using template to provision that infrastructure is infrastructure as code, or provisioning infrastructure as code. And CloudFormation is one service that helps to provision infrastructure from that built code. All right. So once you have the template, we can just upload the template in AWS, and that would spin up the entire infrastructure in sometimes less than 5 minutes, right? So that's how, or that's what made the 3-week rollout possible for UNiDAYS. And then there is WAF, yeah, and then WAF right here. So the WAF and AWS Shield, they actually block attacks and protect the environment from DDoS attacks automatically. DDoS stands for distributed denial of attack. That's like attacks coming from different IP addresses all at one time. Attacks coming to us in a or from a distributed fashion. So AWS WAF protects the environment from those attacks. So the outcome is that UNiDAYS was able to achieve 75% latency improvement. They were able to achieve 100% uptime even during test outages, right? That's covering both predicted and unpredicted outages. And then 40% faster deployments. And now they're able to, or they have scaled globally, and now they're ready to serve millions of users out there. And that's the power of modern cloud native architecture. You can spin up environments and spin up resources, spin up IT infrastructure in cloud in minutes. All right. And we can go live with our cloud IT environment. We can go live in any region we want in a matter of hours, just like that. So if we are building for cloud, and if you're building for scale, if you're building for high availability, or if we are building for global users, right? This is the blueprint. Start small, automate everything, and think global from day one. That's the blueprint. So let's look at the different components that were used in this architecture. So we saw Route 53. Route 53 was the starting point, which is the AWS Global DNS service. It uses intelligent routing. It routes user requests to the nearest AWS region using geolocation and latency-based routing policies. Right, let's go through the different components that were used in this architecture. We saw Route 53. Route 53 reduced the latency of the users, or latency that the users were experiencing, by providing or doing routing based on a policy called latency-based routing. What it does is it directs users to the nearest AWS region. And then there is CloudFront. CloudFront is edge caching service. It again reduces latency by storing the frequently accessed files locally in itself. And CloudFront is a distributed system present in most part of the world in different regions. All right, though the actual IT cloud infrastructure was in EU and in US, CloudFront can actually cache those files outside of EU and outside of US. So when users try to access all the static content, the files that doesn't change, they're stored there and served to the users from there, and only the dynamic ones are pulled from the actual ECS. And then there is application load balancer. The application load balancer distributes the request to the ECS service. We saw two application load balancers, right? They're regional service, and they were like distributing traffic to those ECS running in different availability zones. And then the other component was Amazon ECS with Fargate. That's nothing but containerized microservices run on ECS. And with Fargate, we don't get to maintain any infrastructure, so no infrastructure management. And Fargate especially is scalable, and it's fast in spinning up the containers. That means it's fast in completing those deployments. And then the other component we looked at was DynamoDB, especially the global tables. The global tables kind of replicate the data across region real time, and this ensures consistency for users and session data. DynamoDB is an highly available and an highly performant database in AWS. This again improves high availability and scalability for this architecture. And then the way it was implemented was through AWS or Amazon Event Bridge. And Event Bridge is a service that provides event-driven communication within the architecture, which means that the services don't have to talk to each other directly. Everything is kind of decoupled. They only create events, and the other service consumes that event and acts upon it. And of course, the environment, the IT cloud environment, is present in both regions, and making both regions, the services in both regions, talk to each other is complex. So now we have Event Bridge. If anything happens in one region, it actually leaves an event in Event Bridge, and Event Bridge is a regional, cross-regional service. So it takes the event to the other region, and the service in the other region kind of consumes or becomes aware of what happened in the other region. It alters itself accordingly. And then the whole thing was achieved through infrastructure as a code. Like I explained, infrastructure as code is spinning up the infrastructure by means of code. Let's say we want to spin up another region. All right, go to the code, copy what's in the previous region, or copy the first section, do some minor edits to it, change values which represents the new region. Updated new region is created in less than 5 minutes. And then there is AWS WAF and AWS Shield. They actually protect against distributed denial of service attack, and they also protect with the app layer threats. And these are WAF and AWS Shield are services that protect entry points, protect the surface of the attack. All right, so with the given architecture, and after that got rolled out, right, in less than like 3 weeks, UNiDAYS was able to roll out or build an IT cloud infrastructure in that new region. And now they have customers are happy so as support professional, because they have reduced the latency by 75%. The uptime is now 100%. Deployments are happening faster because of ECS Fargate, and now they have scaled their IT environment in a global level, meaning having an IT cloud environment in a totally different region, totally different country and continent. All that was made possible because of cloud, AWS in this case. All right, I believe that this information that I've shared would have helped you to explore more and learn more about AWS tools and services, and how you can betterment the existing architecture you're working on.